Welcome to the deep dive. Today we're going really small, looking at these tiny creatures called tardigrades.
Ah, yes, the water bears, or moss piglets, some people call them.
Exactly. And they're kind of famous for being, well, almost indestructible, surviving stuff that seems impossible.
That's right.
So our mission today is to figure out how they do it and, what that means for us.
And they're incredibly tiny, it's worth remembering, like half a millimeter long, maybe.
Really small.
Yeah, but built like these little tanks. It's
Yeah.
funny, they were spotted way back in the 1770s.
Oh, wow.
Yeah, this German zoologist, Goes, first saw them. Then an Italian biologist, Spallanzani, gave them their name, Tardigrada,
Which means
a slow stepper, because they sort of amble
sun
along.
steppers. Okay. And you find them pretty much everywhere, don't you?
You really do. High mountains, deep oceans.
Yeah.
But they do seem to love damp moss. That's kind of their classic spot.
Right. But here's where it gets really interesting, the survival stuff. What's the most amazing thing they pull off?
Oh, that has to be cryptobiosis.
Cryptobiosis. Okay.
Yeah, it's like, it's not immortality, not really. It's more like hitting a giant pause button on their entire life processes.
How does that work?
Well, imagine just drying out completely.
Yeah.
Losing something like over 95% of all the water in your body.
95%.
Uh-huh. They shrivel up into this tiny, dry speck called a ton,
A ton?
and they just wait. They can wait out almost anything in that state. And then when conditions improve, maybe water returns, they just rehydrate and walk away.
That's incredible. I mean, I read they even survived in space. That sounds like science fiction.
It does, but it's true. Back in 2007, they sent some up on a mission, low Earth orbit, and they were exposed to the vacuum of space. Some even got hit with direct, unfiltered solar UV radiation.
And they survived that.
Some did, yeah.
Yeah.
Survived and were revived back on Earth. It's just staggering.
What else can they handle? Temperature, radiation.
Oh, yeah. Temperature extremes, no problem.
Yeah.
We're talking down to like minus 200 degrees Celsius, so minus 328 Fahrenheit,
Freak.
and up to boiling and beyond. Over 150 Celsius or 300 Fahrenheit.
Unbelievable.
Oh.
And radiation.
They can take hundreds of times the dose that would be lethal for us. Hundreds.
Okay, how? What's the secret? There must be something special going on inside them.
Definitely. It comes down to a couple of key things. One is they have really, really efficient DNA repair systems. So if their DNA gets damaged, they're just great at fixing it.
Right.
And they also produce these unique proteins. There's one called DSUP, damage suppressor protein.
Visa.
Yeah, and it seems to physically shield their DNA, sort of like wrapping it in bubble wrap at a molecular level, protecting it from things like radiation.
Wow. Like a tiny suit of armor for their genes.
Exactly. And that kind of resilience, it explains how they've been around for so long.
How long are we talking?
Over 500 million years. They've survived multiple mass extinction events that wiped out countless other species. They just endure.
So it's amazing science, but why should you, listening right now, care about this microscopic moss piglet? What's the connection to us?
Ah, well, that's the big question, isn't it? And why scientists, NASA, space agencies are so interested.
Okay.
Think about medicine first. If we could understand how their proteins protect them, especially during drying, could we use similar methods to preserve vaccines without needing refrigeration? Imagine getting life-saving drugs to remote places easily,
That would be huge.
or preserving donor organs for longer. Right now, the window is incredibly short. Tardigrade tricks might help extend that, maybe even help protect human tissues during radiation therapy for cancer.
Okay, so major medical potential. What about space? You mentioned NASA.
Right. Long-duration space travel is really hard on the human body. Radiation, the stresses of space.
Yeah.
Understanding tardigrade resilience, especially to radiation vacuum, could offer clues, maybe even technologies, to help protect astronauts on, say, a trip to Mars.
So learning from them could help us travel further.
Yep.
Maybe even live elsewhere.
It's a long shot, but yeah, that's part of the dream.
Yeah.
But it is important to bust that myth they aren't immortal.
Right, you said it's a pause button.
Exactly. In their active state, they only live for a few months, maybe a year or two for some species. It's the ton state that can last for decades, potentially longer.
Still pretty impressive. And even when they're active, they're doing their bit in the ecosystem, right? They're not just survival machines.
Oh, absolutely. They're part of the microecosystem. They eat plant cells, algae, sometimes other tiny invertebrates. They contribute to soil health, nutrient cycling. Small players, but still important.
It really shows how even the tiniest things can hold some of the biggest biological secrets.
For sure. And the research is ongoing. People are looking into genetic engineering, Can we take tardigrade genes, like the one for DSIP?
And put them into other cells
Hmm.
or organisms.
Potentially, yeah. To see if we can transfer some of that incredible toughness. It's early days, but fascinating stuff.
It really makes you think, doesn't it, about resilience, about survival. What if we as humans could learn to adapt and endure even just a tiny fraction as well as these little water bears do? It definitely poses a big question for our own future.